forecasting for Microsoft Dynamics AX and NAV. So let's start with explanation what is the source. The source is the SQL solution. First, the source of the data is this Microsoft Dynamics NAV database with a company name Kronos 2009 as forecast. So this solution is processed with BI4 Dynamics, and this one creates a data warehouse, BI4 now R forecast 01. Okay, so this is our solution where the staging part is a pure copy of everything what we have seen in the source. We create dimensions and facts, and this is a source for our R. And then we take this data into R, process, and in our case we create a two table, forecast sales by company and forecast sales by customer. I will explain later why do we have a two table here. So let's just see first the data, and the data that are in this analysis cube. So let's see how do the data look like. Let me refresh it. This is the sales cube, and data available are across 5 years from 2013 to 2017 by month, because we generated this data. We sort of control the quality of it, and we created a seasonal pattern. It's not really straightforward because there is some, I would say, randomizing in a discount area, so it's not 100% the same. Just put this away, but this pattern is there. Now we will give R 4 years of data and say, hey, you have 48 rows, please give me your forecast for 2017. But I have already this, so I know what the real data was, and I'm going to compare how good two models are, the one from my project with the one that is there, the visual part. Okay, and we will see how it is. So we know what the source are. There is some seasonality. Definitely there are 12-month period that we analyze by. The model is across 48 rows. This is good. So let's open this. Now if you are a customer and you would just like to run to the end of the show, what you need to know is that everything is run by a stored procedure, and stored procedure are in this job. So the first job is running data from your Microsoft Dynamics and creates a data warehouse, and the second job is running all the forecasting that you need. So if you look what is this specifically doing right now, is executing two scripts, and there is not much to see except that yes, we are executing forecast by company script, and the other one is we are executing forecast by customer, and that's all you need to know how it works. The script that we are running, we are going to see how it works. In order to run the script, you must use SQL 2016, which has enabled R services, which come as a free service in SQL 2016 standard edition ready. And this service then execution of external scripts, then you can run this external script that I'm going to show you right now. So this one is for a customer. So this is the script that does all the job. So it's very technical, it's a SQL, and we will see where the R is embedded. So the parameters are defined. I'll not go into the details. I'll just explain. So these are the parameters that we enter. What do we want to run? So is it a weekly or a monthly forecast, length of the period, confidentiality levels, and some other parameters. But the most important are these. What is the source table? we have to define a time date dimension, which in most cases when we are doing this from data warehouse is posting date, and we have option to define 2 dimension and 1 measure. So everything else is then this is still SQL, and this is where the query, we have to, if you have like 100 million rows in this table, you have to group this table first on a month level. So that's why this is a part of the script here, and we say, hey, you have to ignore data of 2017. I don't want to use them. And here it starts a script. Now this part executes an external script, and here on is a script which I will not show you. This one is for monthly level, this one is for weekly level. So this is all it takes to run your forecasts for sales forecasting by customer. And if I run my 2 scripts here, you see one by one, it is not taking that much time, and the end result will be forecasting based on our data. And actually, you know, the whole process will take about less than 1 minute. Let's just see the history. It takes usually about 40 seconds, which means if you have like a working project would have like 10 predictions, which would take in total about 5 or 10 minutes, depend how much data you have. So with a group total of 100 rows or 50 million rows, you would be still under 1 minute for one forecast, which is quite a lot of data for 100 rows, and which it's still really very fast. So the job has executed here. If we would refresh this data, you see the latest data has arrived, and let's go and see what the results are. So what do we have here? We have a forecasting data for 5 years, and we have created a table in a data warehouse forecast by customer, which is here. I can refresh it. This has been just delivered through the job agent from data warehouse to another data warehouse table, which we are reading now with Power BI. So this is it. If we see what we have is the following. So for the 2017, which is a filter of a visual here, it's 2017, is we have a net sales. We have forecasted numbers by customer. I will explain this later. We have a variance and the difference of 1.52%, which is not bad. Actually, this is good. If we want to see how this looks visual, is this here, or if you want to see it closer, this is here. So this has been done with R. Now, what is important here, was a bottom approach, which means we started with a customer information. So what I mean with a customer, actually I created, as you have seen, data per customer. So I can look into view the data per customer, and you see this customer was not predicted good high variance, but in total is good. And I can also display this data as I want in the visuals that are part of the standard Power BI. Now, if I compare my results with the end result with Power BI is, so this is my project here, and the same line, the same input is put here as a line with a exponential smoothing. The same case, 12 seasonal forecast, 12 points, ignore 2017 and show me the results. If I compare data and put these are 2 visuals one by one, and if I see my project is quite near the real data, and this one, black one, I cannot display the data because it's beyond this, it's a little away. So I would say my prediction with our project is better, And you can say yes, of course, because in case of our visual, only one function is being used, and yeah, we are using 10. Good. So this is understood. Now, I was saying a few times top, bottom, bottom, top approach. What does it mean? It means that when I was creating this data set, I was creating this data set per customer. So you see dimension 1 is customer, and I have more rows here. You see? Now why is this important? Because the forecast is being done on a bottom level, on a detail level, and then the end result is being summed up together, which means the error that I get or the forecast probability that I get on lower level is not improving on a higher level, because I have a lower granularity. Then the end result is not so good compared to if I want to forecast only by a top level, which means company. And this is exactly what I'm doing in my next example. So I was running the same forecast with another job, which I've shown you. There are 2 stored producers, but now I can refresh. Now I have only 12 members, which means this is much more accurate because the aggregates are more compressed, so I don't have this noise. And what is the end result? So this is the same table, net sales forecast by variance when I was using granularity on a customer level, and another forecast by a top level, and the variances, and you see this 1.04%, which is better, and this is really good result. So this is in theory, in practice, the right approach. If you want to see granularity, which you definitely do, then you will sacrifice the forecast accuracy. If you want to go to the top level, then accuracy will go much higher. Now, what does it mean? If you have a lot of items, you want to do it on an item level, you really should analyze your data first, so that you don't have data without any data or blank data, because you will not get a good result. It's good to know the data, and every data science project spends about 80% time on just managing with data. Now happily we are working with ERP, which is already, sort of data are under control, and if you have like data warehouse, then we are even happier because the data are structured, and you can much easier create a forecast because everything is already being integrated on a higher level. So you see 1.04%, and if you look into forecast by company with the visual part, at the beginning the both were very close, like that's this one in Power BI, no, this one by customer and forecast, but then later this one is, the red one is a little better, because here we have this example on a visual level. And if you say, okay, where is now this Power BI forecast with the exponential smoothing, is there is a difference. You see, forecasting is always better because, again, this one is using one function and we are using 10. So this is specifics of forecasting with R. Okay, so let's just sum it up. If you are doing the project, that it will be important where your data are. As we are doing business intelligence for Microsoft Dynamics, we have standardized the process for Microsoft Dynamics AX and NAV, and the source of data in our project will be the for Dynamics Data Warehouse, while in your case, if you are sourcing, you will be sourcing direct data from the ERP. You will need to do some work while this is already set and ready, and additionally we can offer to our customers the features like multiple companies and additional currency for analysis, which are not really straightforward available in another project. When we are in the R, you can develop the same scripts as we do, and we have done this already many times, so obviously there is a project solution approach, so we are really good when we have Dynamics as a source, and we have predefined and preset the parameter that makes sense, predefined out-of-the-box solution, which in your case you have a really good tool or platform to do, but some time will be spent. And then the output. What is the output? We have seen the output in Power BI can be a visual, can be a table. In our case, will be it will be a SQL table. We will put it into a data warehouse. We can put it also directly to ERP as a AX forecast or budget or NAV budget table, and use directly for everything that we have done for data warehouse as a comparison to actuals, which we have done right now, comparing 2017 or to the previous forecast, and do all the time intelligence.